We're going to talk briefly about how to read graphs and tables, as this is an important skill in science. Let's consider a hypothetical example where 3 students are interested in seeing how much their grades improve if they study more for a test. Let's assume these 3 students typically study for an hour each night before a test. In this case, they decide that they're going to increase the amount of time they study by 1 hour for the second test and by 2 hours for the third test. So for the first test, each student studies for 1 hour, and student A gets a 70% correct, student B a 75, and student C a 65. On test 2, they add an hour, studying for 2 hours total each, and student A gets a 90%, student B an 85, and student C an 80. For the third test, they add 2 hours, studying for 3 hours total. Student A gets a 95, student B a 90, and student C an 85. The next step is to calculate the average of our values. The average, or the mean, is simply all of the values added up and divided by the amount of values that we have. In this case, we have 3 points of data for each situation, the 1 hours, the 2 hours, and the 3 hours. So using this 1 hour as an example, we add up 70 plus 75 plus 65, and that gets us 210. We have 3 points of data, so we divide by 3. 210 divided by 3 is 70%, meaning that for these 3 students, an hour of studying results in average performance of a 70% on a test. We then repeat this process for the 2 hours and the 3 hours values. Now that we have the average values, we have a better idea of how studying and the amount of time spent studying improves the test performance. However, a table, while useful, does not provide us as much information as quickly as a graph can. That's the main advantage of a graph. We can quickly see the trends and the outcomes from an experiment more easily on a graph than we can on a table. To create a graph, we typically rely on the averages or the mean results from an experiment. We can then plot those things on the graph based on the independent and dependent variables. An independent variable is the thing that you change in an experiment. In this case, we change the amount of time that students spend studying. The dependent variable is the thing that you measure in an experiment. In this case, they measure their average test performance as a percentage correct of test questions. The control is the thing that you are comparing against. It's the unchanged sample or population. Because our students typically studied for 1 hour the night before a test, the 1 hour data is our control population. Now that we know these things, we can now create a graph. In this case, we're going to create a bar graph, where the values are shown by the size of the bars in each case. On the bottom, we have the x-axis. The x-axis is what goes back and forth, and that is typically where we put our independent variable, or the thing we're changing. In this case, the thing that our students changed was the amount of time they spent studying. On the y-axis, the up and down axis, we typically put the dependent variable, or the thing that we measured. The thing that we measured in this case was the percentage correct on the test. Knowing that, we can then read the graph. For 1 hour of studying, we had an average performance of a 70%. For 2 hours of studying, we had an average performance of 85%. And for 3 hours of studying, we had an average performance of 90%.